All right, we are on problem number 17, I believe, 18, yay! 18 in the ETS 022 Practice Case Math Exam. So, you've got this polynomial and it asks you which of the following is a factor. I want to show you kind of the way that you would do it if you did not have a graphing calculator quickly. Basically, if you've got, this is called, by the way, the rational root theorem. The rational root theorem says that if you list all of the factors of a polynomial's leading coefficient, and here the only factor is 1 of the leading coefficient, and then you list all of the factors of the trailing coefficient, the constant, and in this case that is 6. 6 has factors 1, come on, 1, 2, 3, not 4, not 5, but 6. Okay, the rational root theorem says last over first. There are so many different possibilities for roots, but if there are real roots, rational roots I should say, this is what they're going to be. It's going to be all of these, any combination of the constants factors over any combination of the leading coefficients factors. So it's going to be, and let me just zoom out because again this thing is not wanting to cooperate today. Just FYI, my computer, my Surface has a big crack in it and it's getting just hateful. So not that you needed to know that, not important for rational root theorem, but let's, at least you know kind of why it's doing that. So on this, that means that 6 over 1 is a possible rational root, 3 over 1 is a possible rational root, 2 over 1, 1 over 1. Not only that, so you know that 6, 3, 2, and 1 are all possible rational roots. You don't know the sign of those. So -6 could be a root, -3 could be a root, -2 could be a root, -1 could be a root. The way I usually write it is plus or minus 6, plus or minus 3, plus or minus 2, plus or minus 1. Now the reason that you need those is that in situations where you can't graph this and look at it, and we'll do that in just a minute, what you've got to do is use synthetic division. Synthetic division, and I feel like Tammy's, like, just the box that she draws is slightly different from mine, but you list in descending order the coefficients. I use like an L. I think she uses like a little tiny box, but it's essentially the same thing. Okay, you've got 1x to the third power, no x to the second power, -7x to the first power, and constant of 6. And what you can do is try these different rational roots. So I'm going to try just a positive 1. Drop the first 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is still 1. That would be -7 plus 1 is -6. 1 times -6 is -6. And that leaves 0. If you get a 0 for a remainder by dividing, then you know 1 is a root. Okay, so that means that x minus 1 is a factor. Not only that, you know now that you have, if you take a look at that, you have, this is your answer, x squared plus x minus 6. Okay, and at which point, once you get it down to quadratic, you can actually factor that. What are the factors of -6 that add up to give you a positive 1? That would be a positive 3 and a -2. So here are all of your rational roots. So x plus 3, x minus 2, and x minus 1. Those are all 3 your roots. And so that's this one, and that's all. So the answer is D. But I do want to show you very quickly, you probably could have, and probably should, just for time's sake, put this in your calculator. I just felt it was incumbent upon me to show you the theory behind it. But if you will just enter that, 7x plus 6, that equation in here, you can find it a couple of ways. roots happen where y is 0. So you could go to the table and look for where y's are 0. And remember, we've always got to change that step. Okay. Well, I see that y is 0. I'm going to start at negative 6. Okay. Oops, I didn't hit negative. I hit point. Negative 6. I will get this right. If I start at negative 6 and do a step of 1. All right, here we go. I'm looking for zeros. I know because it's x to the 3rd power that there will be 3. I don't know that they'll all be even numbers, but in this case it ended up that way. And you can see that the roots are negative 3, 1, and 2. But I want you to be very careful about something because it wants the factor. The factor is always x minus that x value. So at negative 3 right here, that's why it's x plus 3 here, because it's x minus negative 3, and x minus 1 and x minus 2. So that's one way to see that. Another way is to look at the graph. You can do it a different way. A lot of different ways you could do. Zoom in right there. And you can kind of see, I don't like that. Let me zoom back out just a minute. Let's just do previous. Okay. There is, under analysis, you can do this and tell it there. Basically, you click right here, hold it down and drag until you're on the right side. And what it does is calculates the 0 for you. So it says negative 3, 0 is one of them. You can do it again right here if you want to. And it tells you that 1 is a 0. And do it again right there. And it tells you 2 is a 0. Okay, so just remember that when you've got negative 3 is a 0, 2 is 0, 1 is 0, that you understand that you have to do x minus that to find the factor. So x minus 1, again, is the only factor that is true of those 4. So D.